Hello friends, this is mock test 17. First question. Any NB are the doping concentrations given in ammeter base and collector if ammeter injection efficiency of the BJT is close to unity. This is your ammeter injection efficiency. That means ammeter injection efficiency is denoted by gamma. Now this gamma is equal to 1 upon 1 plus NB upon Ne. This is the required formula. Okay. Now we have asked if gamma is equal to 1, then what will be the required condition? Put here 1. If I put 1 is equal to Ne upon Nb plus Ne. Okay. This is Nb. So what you will get here, you will get Ne, you will get here Ne nearly equal to 0. Okay. So from this equation we see that Ne is for example here if I solve it as Nb plus Ne is equal to Ne. So this is cancel out, which implies, sorry, Nb is equal to 0, which implies that Nb is equal to 0. That means we have, this is the required condition, that ammeter concentration is very much greater than Nb and Nb is greater than Nc. You can apply your common sense. Okay, so B option is right. Next question. At room temperature means at T is equal to 300 Kelvin. That means this is T is equal to 300 degree Kelvin. We have to calculate the mobility of electrons in the inversion layer of a silicon n-channel MOSFET. So remember, this will be equal to as 1350 centimeter square per volt per second. Always remember, silicon n-channel MOSFET, for that we have mobility of electron is 1350. Okay, next question. A BJT is biased in forward active mode. We know what we have to calculate. These are the given things. Okay, so first of all, IC is equal to IS. Okay, e to the power VBE by VT. Okay, which means this is equal to 10 to the power minus 30. What is this IS? Reverse saturation current. And this is equal to e to the power zero point 0.7 by zero point 0. Here it is 25. When you will solve, it will come out to be as 28. That means we have, after solving this, we get IC is equal to what? IC is equal to 0.144 milliampere. Now we know that GM is equal to we have GM is equal to IC upon VT. So GM is equal to 0.144 upon, what is this thermal voltage? It is given as 25 millivolt, 0.025. After solving this, you will get it as 5.76 milliampere per volt. So the right answer is 5.76 milliampere per volt. Okay, 5.76. Next question. Consider the following two statements. We have been given what we have given S1. Okay. So first of all, let me tell you one thing. I have already told you many times that if this is your MOSFET, okay, this is your MOSFET. These are two N plus regions, okay, and this is your P substrate. This is your P substrate. This is your SiO2 layer. This is your SiO2 layer. This is your source. This is your drain. This is your polysilicon pattern, which is termed as gate terminal. Okay, now you should be aware that the region between these two N plus region is called channel region. What it is called as channel region. Okay, now this negative, if I apply a voltage, for example, if I choose this green pen, okay, if I apply a negative voltage here, Okay, this is what? This is VDS. This is what? This is VDS. Now remember, the negative terminal of the battery repels with the electrons in the n-channel region. Okay, it will recombine with the holes in the p substrate, and then therefore no electrons reach the drain side, so no current flows. So here no current flows. Drain current will be zero. If the channel is of n region, if channel is n region, if I say here, if if channel is n region, then Vg is greater than Vt. In order to establish the channel, we have to put gate voltage greater than Vt, which implies that Vg minus Vt should be positive, which implies in order to establish the channel, VDS should be less than VGS minus Vt. Okay, this is known as active linear or triode region. What it is called as active linear or triode region. So we have given that NMOS is in triode region, because what we are going to do, we are going to establish a channel. We are going to establish a channel. So if VDS is less than VG minus VT, if VDS is fed, okay, if apply, for example, if apply a voltage of VDS is equal to 2 volt, then drain voltage, we can say that this drain voltage is more positive than the source voltage. That means any type of semiconductor, whether it is p type or n type, is electrically neutral in nature. So this 2 volt entirely drops across this channel region. If it is around 2 volt, okay, increase if I increase the voltage, for example, it is 2 volt, it is 2 volt. So here it will fall as 0 volt. Here it will be as 1 volt, it is 0.5 volt, and it is 1.5 volt. So entire 2 volt will be dropping across the channel. So the channel potential increases from source to drain. It means the second statement is right statement. Here, second statement is absolutely right, that the channel potential increases from source to drain. Since at high reverse bias voltage, there will be high depletion region. The depletion region will be high. Then the depletion width will be high. Depletion width will be high, which penetrates more into lightly doped region. Okay, which penetrates more into lightly doped region. That means the channel potential increases from source to drain. As we can say also, that is in this N channel MOSFET, there are two PN junctions. There are two PN junctions. One is N plus P type substrate, and the other PN junction is this drain N plus region with this P type substrate. So channel is the inversion layer. What if we talk about the inversion layer? The channel is inversion layer, and drain PN junction is more reverse bias than the source PN junction. Here we can say that this drain PN junction, this drain this drain PN junction is more reverse bias than the source PN junction. So the region which is more reverse bias has high depletion region, and it penetrates more into lightly doped region. So this is the right statement S2. This is the reason. And the first statement, that the inversion charge decreases from source to drain, yes, because as VDS increases, then channel area reduces. Channel area reduces from source to drain, which implies that inversion charge reduces from source to drain. That means absolutely both statements are absolutely right. Okay, so here both S1 S2 are true, and S2 is the reason for S1. Next question. If the base width in a BJT is doubled, which one of the statement will be true? So here, if this is a transistor, okay, this is your this is your ammeter, This is your base, this is your collector. Okay. So this is emitter based junction, this is collector based junction. This is forward biased, this is reverse biased. Current gain will increase. As we know that if base width, when the base width reduces, then the recombinations will be reduced and therefore the IV will be reduced. So IC will be nearly equivalent to IE. Okay. So you can say that beta is equal to IC upon IE. Beta will increase how? When the base width is doubled. Base width is doubled. That means here IC reduces for same value of IC, for same value of previous IC, because when base width reduces, then IB reduces. Okay, then IC is nearly equivalent to IE. Here IC is nearly equivalent to IE. Okay, I can write here as IC is nearly equivalent to IE in this condition. So when IE is reduced, when IC is reduced, then beta will have to, when beta is equal to IC upon IB, it will be IB. What it is? Beta is equal to IC upon IB. When the electrical base width is increased, that means base current is increasing. That means the beta is reduces and IC is, because IC is reducing. So this is absolutely wrong statement. This is absolutely wrong statement. Unity gain frequency will increase. You know that Ft, F tau. This is, F tau is the unity gain frequency where the common emitter short circuit current gain tends to unity, falls to unity. If I draw a graph, here, okay, this is your what? This is your common emitter short circuit current gain, and here the value uh, is around 1 by root 2, and here it goes to unity, and then it is what? This is beta cutoff frequency, and this is F transit frequency. So unity gain frequency will increase. We have the formula that this Ft, okay, or F tau is equal to dV by pi w square. Okay, that means this unity gain frequency is inversely proportional to the electrical base width. So if it is increased, then it has to be reduced. It is also wrong statement. Ammeter based junction capacitance will increase. No, we can say that see, f tau is equal to what? We have the formula HFE f beta. Okay, we have f tau is equal to HFE F beta. So HFE is the forward current gain. HFE is what? This is the forward current gain when output is short circuited. When output is short circuited, that is the maximum current in the output. We have Ft is equal to Gm upon 2 pi of Cc plus Ce. Okay, we have Cc plus Ce. If, because Ce is very much greater than Cc, then what we have, if I just rub this in order to have the space. Okay, so Ce is very much greater than Cc. That means Ft is equal to Gm upon what? Gm upon 2 pi Ce. 2 pi Ce. That means emitter based junction capacitance, when it will increase, when this will have to be decreased. Okay, so this is the right answer. That means Ce is equal to Gm upon 2 pi ft. So when ft in the last option, we said B, in the B option ft was reducing. So when it is reducing, it has to be increased. So this is the right answer. Early voltage will increase. This is wrong statement, because in any ways early voltage, as we can also say, if I rub it, okay, if I rub it and if I say that as base width reduces, then IB reduces. But here, as base width is increased, so IC will be reduced, and which implies that the early voltage will reduce. Okay, so VCB, early voltage means the collector to base junction voltage. If it reverse voltage, if it is increased, then the equivalent base width reduces because IC increases. And you know that early voltage, if I draw a graph, if I draw a graph between IC versus VCE, okay, so the graph will come out to be as this way. Okay, sorry, it will like this way, and the whole slope will meet at this point. Okay, so this is V, this is the early voltage, magnitude of the early voltage. You know, the reverse bias voltage, on the variation of the reverse bias voltage there is the variation in the width of the base region. This is known as early voltage, and the voltage is collected to base voltage. So right answer will be C only. The D option is absolutely wrong. D option is absolutely wrong because as bandwidth is doubled, IC will be reduced. As IB is increased, so beta has to be reduced. So VA is reducing, it is not increasing. Thanks. If you please like my video, please share and subscribe. Please do like my video, it is very important.